This is going to be a screencast primarily about divisibility rules. It's going to be one of the screencasts that I'm going to post that kind of you can go back to if you need a refresher on some of the basic things that you just need to remember in order to do just general math. So divisibility rules, meaning like, how do I figure out if a number can be divided evenly by a certain digit? Okay, so here are your rules. If the last digit of a number is either 0, 2, 4, 6, or 8, meaning it's an even number, then it's going to be divisible by 2. If the sum of the digits is a multiple of 3, then it's going to be divisible by 3. If the number formed by the last two digits is a multiple of 4, or like if the last two digits are a number that's a multiple, of 4, it's divisible by 4. If the last digit is 0 or 5, it's going to be divisible by 5. If the number is divisible by both 2 and 3, then it is also divisible by 6, because remember, 2 times 3 is 6. 7 is kind of a doozy. If you double the last digit subtracted from the number formed by the rest of the digits, and it's 0 or a multiple of 7, then it's divisible by 7. So that one's going to be a bit of a mouthful. That's going to be the hardest one probably for you to remember. If a number formed by the last 3 digits is a multiple of 8, if the sum of the digits is a multiple of 9, if the last digit is 0. So there are your divisibility rules. I think what the easiest thing is I'm just going to start walking you through some of the things that you're going to review on your own. I'll do some of them with you, and then you can do the rest of them kind of on your own for practice. Okay, as you guys get to know me, you're going to begin to understand that I'm kind of a very visual person. So what I have done already is I'm going to put a yes in green if it's divisible by whatever digit we're talking about, and I'm going to put a no or an N in red if it is not. So we're starting off with some numbers that are fairly easy because these numbers only have like 2 digits. And I'm not going to do all of them with you, but I'll do some of them. So for instance, I think it's easier for us to test all the numbers by a certain divisibility rule. So that's what we'll do. So I'll do maybe the first 5 or 6. Okay. Is it divisible by 2? Yeah, because it's an even number. Is it divisible by 2? Yes, it's an even number. Or in other words, is the last digit a 0, 2, 4, 6, or 8? So yes, it's divisible by 2. Yes, because it's 0, 2, 4, 6, or 8. Yes, because it's 0, 2, 4, 6, or 8 in the last digit. Yes, because it's an 8. No, let me get my red, because it's a 3. It's an odd number. Okay, and you can do the rest of them for the divisibility rule of 2. All right, now we're going to look at 3. Is 40 divisible by 3? Well, I don't know. Is the sum of the digits a multiple of 3? Well, 4 plus 0 gives you a sum of 4, and 4 is not a multiple of 3. So when you take 40 and divide it by 3, you're not going to get a nice whole number. You're going to get some sort of decimal. So we say nope. All right. 36. Is the sum of the digits a multiple of 3? Add the digits. 3 plus 6, that's 9. Is 9 a multiple of 3? Yes, it is. So is 36 divisible by 3? Yes, it is. 14. Again, that's not y'all's bell, so don't get excited. 1 plus 4 is 5. And is 5 a multiple of 3? No, it is not. So 14 is not divisible by 3. 66. 6 plus 6, those are your digits. 6 plus 6 is 12, and 12 is a multiple of 3, so 66 is divisible by 3. 48. Your digits, 4 plus 8. 4 plus 8 is 12, and again, 12 is a multiple of 3, so yes. Your digits are 9 and 3. 9 plus 3 is 12. Is 93 divisible by 3? Yes. Okay. All right. If the number formed by the, so now I'm probably going to just cut it down and do maybe like 3 examples for each of the rest of them. If the number formed by the last 2 digits is a multiple of 4, is this a multiple of 4? Yes. So it's divisible by 4. Okay. Is 36 a multiple of 4? Yes, because 4 times 9 is 36. So it's divisible by 4. Is this a multiple of 4? Because right now, remember, we're looking at numbers that only have 2 digits. So we're basically saying, is that a multiple of 4? And no, it's not. All right. Again, I'm not going to keep doing all the rest of them. 5 is pretty simple. If the last digit is 0 or if the last digit is 5, then it is divisible by 5. So 40 is divisible by 5, but 36 is not, 14 is not. Okay. If 6, it's divisible by 6 if it's divisible by both 2 and 3. This one was divisible by 2, but not by 3. This one was divisible by both 2 and 3. This one was divisible by 2, but not 3. It's only divisible by 6 if it's divisible by both 2 and 3. So 36 is divisible by 6, but 40 is not divisible by 6, and 14 is not divisible by 6. Like, can you still take 14 and divide it by 6? Yeah, absolutely. It's just you're not going to get a whole number, okay? All right. If double the last digit, okay, double the last digit, double 0 is still 0, and you subtract that from the number formed by the rest of the digits, well, the only other digit is 4, so 4 minus 0 is 4. Is that, it says formed by the rest of the digits, is 0 or a multiple of 7? Double the last digit with just 0, and 4 minus 0 is 4, so you didn't get 0, and you didn't get 7, so it is not divisible by 7. All right. Again, if you take the last, and these are double-digit numbers, you really should know your multiplication tables. So, really, you should know immediately that this is not divisible by 7. But let's use the rule: take the last digit and double it. 6 times 2, that's 12. 3 minus 12 gives you -9, which is not 0, and it's not a multiple of 7. So it's not divisible by 7. All right. The next one, take the last digit, 4, double it, which is 8, okay? And then subtract it from the rest of the digits. 1 minus 8 gives you a -7, okay? And we're going to go ahead and -7 is a multiple of 7.